Alright everyone, today we are going to talk about Lesson 13, the graph of a linear equation in two variables. So we're going to start off by kind of doing what we did with Lesson 12. It says, let's find 5 solutions to the linear equation x plus y equals 6, and then we're going to plot them on the coordinate plane. So let's pick our x values. If your values aren't given, I always like to do 0, 1, 2, 3, 4, 5, and 6. Just keep on going. So if I would plug in, here's my equation, x plus y equals 6. Remember, if I plug in 0 for x, 0 plus y equals 6. 0 plus what gives you 6? You should get 6. The next one, if I plug in my 1 for x, 1 plus y equals 6. 1 plus what gives you 6? You should have a 5. My next x value is a 2. 2 plus y equals 6. 2 plus 4 gives you 6. The next one, 3 plus y equals 6. 3 plus 3 gives you 6. And you can continue this on for x values of 4, 5, and 6, and you're going to start to see a pattern. As my x values are increasing by 1, my y values are decreasing by 1. So if I keep on decreasing by 1 every time, you should have a 2, then a 1, and then a 0. So we are going to start to plot this now. So on your coordinate plane, let's make an xy axis. It's kind of hard to do on this, so ignore my squiggly lines. So I'm going to say that every increment is a 1. So if I plot the point 0, 6, I would stay 0 on my x-axis and go up to 6 on my y. 1, 2, 3, 4, 5, 6 is about here. My dots aren't really working so nicely. Then 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and 6, 0. That's what your graph should look like, and hopefully you are able to do this because it was basically what you did in Lesson 12. But if you still don't understand, make sure to ask your teacher. So the next question says, can you predict the shape of the graph? And as we just look right now, so far this looks like it is going to be a line, and actually my line is decreasing. So as of right now, I would predict that it's probably a line. But to be honest with you, we're not sure. Because if we look below at this graph, it still has the points plotted accurately, but you see how it could technically be a curve because it still goes through all of those points that we came up with from our table above. It still passes through all those points. So the next question says, the only thing we can do at this time is to find more points or solutions that would show what the graph looks like between the existing points. That means we will have to look at some points with coordinates that are fractions. So we now are going to continue our table, but this time we're going to go in between, and then that may help us see what the shape of the graph would look like a little bit more realistically. So if we continued on with the equation, x plus y equals 6, and if I plugged 1/2 in for x, so if I did 0.5 plus y equals 6, 0.5 plus what equals 6? Well, it's 5.5. And then if I did 1.5 plus y equals 6, 1.5 plus 4.5 equals 6. So now I want you to pause the video and try to fill in for 2.5, 3.5, 4.5 for x. Come up with your y values. Once you're done doing that, I want you to go back to the top and plot on the same coordinate plane what you had when you completed this table. Once you do all of that, then you can press play and check your answers. So pause your video now, please. So if you did this accurately, you would have had 3.5, 2.5, and 1.5. And remember, all I did was plug in my x values into the equation to find out something plus another number gives you 6. Once you did this, you should have gone back up, and I plotted those new ordered pairs in green. So I plotted those new ordered pairs in green, and you would have something that looks like what I have drawn up here. And if you're not sure how I'm coming up with this, please ask your teacher at this time. If you're good on what the work I showed you so far, please go to your next page. So it says, we already added the points. So now it says, are you convinced that the graph of the linear equation x plus y equals 6 is a line? So if we went back and looking at this, for the most part, yeah, this looks like it would be a straight line no matter what. So I'm going to say probably. But they want us, of course, to check more points. So, but let's check more points, just to be on the safe side. So down here it says, now it's time to find more solutions. This time we need to come up with solutions where the x value is negative or the y value is negative. So if you look at your table, we've already done all of this work that they already have in here. We're going to fill it in for these values now. And if they don't give you a table of values, like I said, you can make up your own x values, plug them into the equation to get your y values. So remember, our equation that we are working with is x plus y equals 6. So if I plug in my first x value, -1, so I would write -1 plus y equals 6. -1 plus what gives you 6? If you're unsure, remember you can solve it. Get y by itself by doing the opposite operation. So I would have y equals 7. Then we're going to plug it in for -2. -2 plus y equals 6. You could think in your head -2 plus what gives you 6, or solve it by adding 2 to both sides to isolate the variable. So I would have y equals 8. I want you to pause the video, fill in the table for the rest of these, and when you are done, you may press play. So if you did this accurately, you would have came up with 9, -1, and -2. So like I said, if you're unsure on how I got those, all I did was plug in my x value and solve for y. Now this question says, now we have 15 solutions in this table to the equation x plus y equals 6. Are you convinced that the graph of this equation is a line? So if you look on your next page, they actually graphed it for you. So if we look, does this follow a straight line that it's looking like it's looking to be? And I would say yes, definitely. By now you can see that this shape, no matter what, is going to be a straight line. Remember, the equation that we were using was x plus y equals 6. Eventually we are going to see that anytime we graph a linear equation, it will always be a line. And we know from our previous units that just by looking at the equation to know if the equation is linear or not, look at your exponents with your variable. Remember, if they're a 1 or a 0, it is linear. And in this case, my exponents with my variables were a 1. So that's another way to tell that no matter what, this would be a line. The next question says, based on the look of the graph, does the point 17/3, 1/3 belong to the graph of the linear equation? Why or why not? So let's just look at the graph. So 17/3, if you take 17 and divide it by 3 in your calculator, you're roughly going to get 5.6. And 1/3 roughly in your calculator is 0.3. So I'm going to actually graph this point. I'm going to estimate where 5.6, 0.3 would be, and it would be somewhere around there. Does this look like it's fitting the shape of the straight line of my graph? And indeed it does. So for this question, I would say yes Whoops. I would say yes. It looks like it would fit. Because when plotted on my graph, like what we did right here, it fits the pattern, or it fits the line pattern. So if you run across a question like this, try to plot it and see if it follows the shape, because obviously if I plotted it and I had something up here or over here or down here or over here, those are not on my line, so they are not solutions because they do not follow the shape of the graph. So I'm going to erase those. Now, just by looking at the graph or on the next question, we cannot be totally sure. So we can predict that 17/3 1/3 is on the graph of this equation because it looks like it should be. But what can we do to find out for sure? Well, as always, to find out for sure, what you're going to do is plug it in to the equation. So I'm going to say plug into equation. So here's my equation. I have x plus y equals 6. So remember, in an ordered pair, it always goes x and then y. So I would do 17/3 plus 1/3. I want to know if that equals 6. Well, since I have the same denominator, a common denominator, I just add my numerators together. So 17 plus 1, I'm going to write it over here because I'm running out of room, gives me 18/3. I want to know if that equals 6. And what is 18 divided by 3? Well, in this case, it is 6. So since both sides equal the value, yes, it's a solution. So, like I was trying to tell you, we can estimate by plugging it in on the graph, but to only know if it's for sure, you can plug it into your equation. This is also what we did in a previous unit by plugging and chugging in our values to see if it's accurate or not. So for this next one, just by looking at the graph, would you say that -2 3/7, comma 4 is a point on this graph? So -2 3/7 is roughly -2.4. So, and my y value is 4. So I'm going to go back up to my graph and see if -2.4 is a point on my graph. So let's go up. When x is -2, y is 4. They want us to plot this point, -2.4, whoops, comma 4. So if I plot that, I'd have something right here. Does this point here even touch this line or come remotely close to that line? Well, I hope you can say that the answer is no. So, what you're going to put down here, that it's no. Not even close. How do you know that the graph does not curve down at that point? How can you be sure? Well, remember, just like before, I said the only way to be super sure is to plug into the equation. So if we did that, remember my equation is x plus y equals 6. My x value in this case is -2 3/7. My y value is 4. I want to know if that equals 6. And so if I did -2 3/7 plus 4 in my calculator, I would get roughly -1.6. -1.6 is not even close to 6. So remember, the only way to be sure is to plug into the equation. So it says at this point we can predict that the graph of this linear equation is a line. Does that mean that the graph of every linear equation is a line? Might there be some linear equations so that the graphs of those linear equations are not lines? For now, our only method of proving or disproving our prediction is plotting solutions on a coordinate plane. The more we learn about linear equations, the better we will be able to answer the questions just asked. So far we are just plotting solutions on the coordinate plane. Alright, so let's start looking at the classwork a little bit. For exercise 1, it says find at least 10 solutions to the linear equation 3x plus y equals -8 and plot the points on the coordinate grid. So this is something you should be fairly comfortable with doing because lesson 12 sort of focused on this a bit. It does not matter what x values you choose because no matter what, we still should be getting the same shape whenever you graph it. So let's just pick some random x values. I'm going to choose 0, 1, let's throw in some fractions, 1.5, 2, -1, -2, -3, -4, -5, and -6. No, your values that you plug in for x do not matter. You should, though, when you plot it, get the same shape of a graph that I will get over here when we eventually plot it. So there's not enough room right here for me to do this, but I'm just going to show you what it would look like. So for when x is 0, I would do 3 times 0 plus y is equal to -8. So I'm going to continue to show the work right down here. So 3 times 0 is 0. 0 plus y is equal to -8. You might know what that is just by looking at it. If not, if I get y by itself, by isolating the variable, I would subtract 0 from both sides to give me y equals -8. So in this case, y would be -8. Same thing, if we try when x is 1, I would do 3 times 1 plus y equals -8. I'm going to erase what we have here. So 3 times 1 is 3 plus y equals -8. So if you don't know what that value is, remember, solve for y. So the opposite of adding 3, I would subtract 3 from both sides to give me y equals -11. Let's try one more together. So for the next one, if I do 3 times 1.5 plus y equals -8, 3 times 1.5 is 4.5 plus y equals -8. I would subtract 4.5 from both sides, and in this case y would be equal to -12.5. Why don't you right now try to finish the rest of these, pause your video, and when you're ready to reveal your answers and check the work what I have, you can press play and see if you were correct. So if you did this correctly, you would have had these values, -14, -5, -2, 1, 4, 7, and 10. Remember, all I did was plug in each one of my x values into x in the equation and solve for y. Your next step would be to plot your data on the coordinate grid. So that's what I'm about to do. So I'm going to make sure to label my x and y axes. So remember, this is your x, this is your y, whoops, this is your y. And since my x values range from 0 to -6, I'm just going to make each one of those values a 1. So I would have 1, 2, 3, and then we would be going backwards by -1. However, for my y values, because I have, my y values range from a -14 as my smallest to +10 as my largest, I'm going to go off by 2's on my y-axis. 2, 4, 6. Make sure you know -2, -4, and so forth. So that's my scale for my x and y axis. So then you just plot your ordered pairs. Remember, your ordered pairs always x, y. So for the first one, I would plot 0. I'll write it down here for you to see. The first ordered pair I would plot would be, whoops, would be 0, negative 8. So if I plot the ordered pair 0, negative 8, 2, 4, 6, 8, it would be somewhere right around there. And if I plot the ordered pair 1, negative 11, it would be somewhere here. 1.5, negative 12.5. So 1.5 would be about here. 12.5 is actually going to be off my grid, but let's just estimate it to be about here. 2, negative 14 is way off my grid, so I'm not even going to plot that just because I ran out of room. On your test, though, and on our review, make sure that you draw your scale large enough so everything fits. The next one I would have would be negative 1, negative 5, which is here, negative 2, negative 2, negative 3, positive 1, negative 4, positive 4, negative 5, positive 7, and lastly, negative 6, positive 10. So I hope you can start to see my line in green, my green dots. So then if we go to the question, it says, what shape is the graph of the linear equation taking? Well, if we start to look at this, this definitely looks like a straight line. So this linear equation is making a straight line graph, because actually I could start to connect my data points, and I know it's hard to draw a straight line on here, but it would be roughly forming a straight line. Moving on to number 2. Number 2, you are doing the same exact thing. So remember, it does not matter what x values you plug in or what y values you plug in. And actually in this case, I'm going to plug in y values because it's going to be easier for me to get my x values. But like I said, it does not matter at all. So if I just pick random y values, and remember you can pick any values that you'd like, so I'm going to pick 0, 0.5, 1, 1.5, 2, 2.5, 3, negative 1, negative 2, negative 3. Remember, you do not have to pick the same y values as I did. You could have chosen x values. The reason why I chose y values, it's going to be easier for me to solve the equation. Next step is to plug it into the equation. So if I plugged it in, I would have x minus 5 times 0 is equal to 11. So if I wrote that down, x minus 5 times 0 is equal to 11. Would have x minus 5 times 0, 0. To get x by itself, I would add 0 to both sides to give me x is equal to 11. I will do another one with you. So the next one I have is x is equal to 1/2, or 0.5. So I have x minus 5 times 0.5 is equal to 11. X minus 5 times 0.5 is equal to 11. If we start solving this, I would have x equals 5 times 1/2 would be 2.5. Whoops, I made a mistake. Put an equal sign instead of a minus sign. The opposite of subtracting 2.5 would be adding 2.5 to both sides. So we have x is equal to 13.5. I want you to try the rest of these on your own, and then pause your video, and when you have your x values, you can press play and see if you got them correct. So if you did this accurately, these are the values you should have. Double check your work. If you did it incorrectly, remember you were doing x minus 5 times whatever your y value is equal to 11, and then you'd simplify and solve. Your next step, as always, is to plot it. So we are going to plot it on our coordinate grid. So draw your x and your y axis. Remember, this is your x, this is your y, and your ordered pairs are always x comma y. Okay, so for my scale for my x-axis, I need to go the whole way to positive 26 and down to negative 4. So I might increment by 4s on my x-axis, so it would be 4, 8, 12, and so forth, negative 4, negative 8. On my y-axis, I just have to get from a negative 3 to a positive 3, so I'm just going to increment by 1s here. So make sure you're incrementing like I am, and I want you to pause your video and plot your graph and see if you came up with the same line that I have. So your line should be looking like something like what I have in yellow, or the shape of your graph. So when it says what is the shape of the graph of the linear equation taking, I would say that it's taking on the shape of a straight line. Remember, it does not matter which points you chose to plug in, no matter what, you will be getting a graph that looks very similar to this. Your scale might be different, but your graph still is going to look the same. We're now going to skip 3 and 4. If you go to number 5, the question says, Joey predicts that the graph of negative x plus 2y equals 3 will look like the graph shown below. Do you agree? Why or why not? Well, the first thing I would do is look, does this look to be like a straight line with all of my dots? So if I started to connect my dots that I could into a straight line, all of those would work. So for my first step, I might plug that into my equation. So I'm going to plug a value into the equation and see if it works. So the ordered pair of what I circled is 0, 0. So if I plug that into my equation, negative 0 plus 2 times 0 is equal to 3. Let's see if this works. I would have negative 0 plus 2 times 0, 0. Well, 0 is going to be on this side. Does 0 equal 3? No. So this graph that they gave us would not be the graph of this equation, because this specific ordered pair does not work when we actually plugged it into my equation. We are going to skip number 6 for the moment. So what I want you to know is, please remember the lesson summary. One way to determine if a given point is on the graph of a linear equation is by checking to see if it is a solution. Note that all graphs of linear equations appear to be straight lines, so that's what you have to remember. Your homework is to do numbers 1 through 7 in the problem set. For number 1, it's going to be beneficial if you make an XY table, and I will just give you different X values to plug in. To your equation for Y, and then make sure you set up your graph and plot it. So for number 1, you are just going to plug in these values into your equation. You're going to get your Y values, and then you will graph it on this coordinate grid. Make sure to use an appropriate scale based off of your values. And then talk about the shape. For number 2, you want to see if these points, all of them, will fall on this graph. Make sure you remember what we talked about as to be linear or nonlinear. And that's basically what you are going to do for 3. For 4, the same thing. You want to see if all of those will fit into that equation. 5 as well. Same with 6 and 7. So basically only number 1's the actual one you have to graph. Everything else after that, you're going to see if all of those points would work into your equation by plugging and chugging. Well, I hope you understood this material. If not, make sure you ask your teacher, and thank you and have a great day. Remember, your homework is numbers 1 through 7 in the problem set.